So for this video, we're going to look at finding the greatest common factor and then applying that to factoring binomials and polynomials. So in this video, it's a bit longer, but what I want to make sure that you do is know that you can pause the video and try some of them and then unpause the video to see the answers. So you don't just have to watch. In fact, you can watch a portion of the video and then try some, fast forward, do whatever you can so that you understand the material to the best of your ability after watching whatever you choose to watch of the video. So the goal of this lesson is to be able to factor binomials. But in order for us to learn how to factor binomials, we have to make sure that we could factor the two monomials. So if I were to ask you to find the greatest common factor of 24 and 36, some of us would just start listing the factors of 24 and 36 and find the largest factor that those two numbers have in common. The way that I like to do it is I like to use the ladder method, because the ladder method ensures that we don't miss the greatest common factor when we are listing out factors. So in order to do the ladder method, I ask myself, what is a common factor of 24 and 36? Some of us are going to go right away and say 4. Some of us would say 2. Either way, so let's do 4. 4 into 24 is 6. 4 into 36 is 9. Now I ask myself, okay, 6 and 9, common factor would be 3. I'm left with 2 and 3. Common factor of 2 and 3, there aren't any. So I look at my side and I say, okay, my greatest common factor will be my 2 factors that I pulled out multiplied together. I could have had 3 factors or 4 factors multiplied together, or I may have been the person that right away saw that the greatest common factor of 24 and 36 was 12. However you did it, it's going to be the product of the numbers that you factor out. So let's go ahead and try something with a variable now. We have 32x and 18x. So I'm going to pull up, first I'm going to factor out the numbers. So I'm only going to focus on 32 and 18. And my common factor there is 2. So I'm going to do 16x and 9x. And then I go, there are no numerical factors of 16 and 9, but I do see a common x there. So I'm going to go ahead and factor out an x. And I get 16 and 9. Now there's nothing else that's in common there, so I'm going to multiply my two numbers, my number and my variable, and I'm going to get 2x is the greatest common factor between 32x and 18x. My last one, now it's a bit trickier because now I have x squareds involved. I'm still going to first focus on my numbers, which is I'm going to go ahead and try to factor out a 5, so it's 8x squared and 5x. Yeah, there's no other number factors of 8 and 5, but I do see that there's some x's involved. Now, I should know that x times x equals x squared. So an x squared and an x have one x in common. So my greatest common factor between those two would be 5x, because I would factor out an x, and I'd be left with 8x and 5. So using that idea, now I'm going to factor binomials. My goal in factoring binomials is to have the product of the greatest common factor times whatever is left, the binomial that is left after I factor out the greatest common factor. So I'm going to set up my binomial just like I would have set up my ladder to find my greatest common factor. So I'm going to look at that and I'm going to say, oh, my factor, a greatest common factor is 10. So that would be 5x and 3, because 10 goes into 55 times 10 goes into 33 times. I'm going to bring down my sign, which is a plus. There are no more common factors of 5x plus 3, so this is my fully factored binomial. I'm going to put 10 times in parentheses 5x plus 3. So basically what I'm doing is undistributing. I'm fully factoring a binomial, so the binomial becomes an equivalent expression, which includes the greatest common factor and a fully factored binomial. So in this case, 50x plus 30 is equal to 10 times, in parentheses, 5x plus 3. And just to test it out, I could distribute that 10, and I would end up getting back to 50x plus 30. But my final factored answer is 10 times 5x plus 3. That's my fully factored answer. So again, I'm going to factor 14x minus 7. I'm going to factor out the greatest common factor, well, a common factor, which is 7. I'm going to be left with 2x and minus 1. I'm going to look at that. I'm going to say, 2x and minus 1 have nothing in common. There are no common factors. So my fully factored binomial would be 7 and then in parentheses 2x minus 1. And again, I could test the waters by distributing that 7 and I would end up back at 14x minus 7. Last one is the hardest one because now you're dealing with multiple x's. Focus on the numbers first. The common factor of 24 and 18, any common factor of 24 and 18, I'm going to go with 6. I'm going to be left with 4x squared minus 3x. My numbers are now fully factored, but my variables aren't, so I can factor out an x, and I'd be left with 4x and minus 3. So my greatest common factor is 6x, and my fully factored binomial is 4x minus 3, making the factored binomial 6x times 4x minus 3. So now these get tricky because when the coefficient of the variable with the largest exponent is negative, we're going to factor out a negative as well. So our greatest common factor for the first one is actually going to be a negative because we have a 2, which is the coefficient of our largest variable. Because our variable is x, the exponent is 1. This 4 doesn't even have a variable. So I'm going to go ahead and set it up just like I would set up the other two problems, except now instead of factoring out a positive 2, I'm going to factor out a negative 2. And when I factor out a negative 2, I'm dividing negative 2x by negative 2. So I'm going to be left with x, or 1x. And I'm going to be factoring out a negative 2 from negative 4, which is actually going to give me positive 2, because negative 4 divided by negative 2 gives me positive 2. So my fully factored binomial is x plus 2, and my greatest common factor is negative 2. So when I were to distribute that negative 2, I would end up getting negative 2x minus 4. So again, here is a binomial. The variable with the largest exponent is x squared. The coefficient of x squared is negative, and therefore I'm going to factor out a negative when I factor out the greatest common factor. So the greatest common factor of negative 6 and 12 will be negative 6. Okay, again, this number doesn't always have to be my greatest common factor. It could be any common factor, but then you're going to have to keep going through the steps to get the greatest common factor. So if I factor out a negative 6 from negative 6x squared, I'm left with x squared, and then minus 2x. There's an x in there. I'm left with x minus 2. So when I multiply these two together, I get negative 6x, and inside parentheses is x minus 2. That is my fully factored binomial. If I were to distribute the negative 6x, I would get negative 6x squared minus 12.